Hi everyone, welcome to the channel. Today let's discuss Euclid's division algorithm. In previous lesson we have discussed Euclid's division lemma. So today we see how do we use that Euclid's division lemma in Euclid's division algorithm. So yeah, let's say two given integers a and b are there. A and b. So here a should be greater than b. Let's take a is greater than b, and yeah, we can write. Yesterday we learned how do we write a is equals to bq plus r. We can write using the Euclid's division lemma. So this is here. Now the next step depends on whether the based on the remainder. This algorithm goes like this. If the remainder is 0, then the HCF of a and b is b itself. So b is the HCF. Then we just stop the algorithm there itself. If the remainder is not 0, then what? See here, if remainder means r is not equal to 0, if r is not equal to 0, apply the division lemma to b and r. So now the same division lemma, Euclid's division lemma, what we have studied in previous lesson, is like, so we applied the division lemma to b and r. Here b is always greater than r, because Euclid's division lemma we know r is always less than b only, based on this rule. Remainder is always less than divisor, right? That we have studied and we know. So now we apply again to Euclid's division lemma to b and r. The same again we will repeat. So in this case, here we treat it as this, we treat as a, and this we treat as b, and we continue the same process till the remainder gets 0. At the stage where remainder is 0, then the HCF of a and b is the divisor b at that stage. So let's see with one example. So let's say let's say two numbers are given, 135 and 225. Here this Euclid's division algorithm main goal is to compute the HCF, highest common factor. So in the next lesson we see with a few examples what is HCF mean, and beauty of HCF, practical examples also. So for now let's stick to one example. So here as I already told, a should be greater than b before we considering the a and b values. So this is going to be the value a, this is going to be the b. So here like this. So we can write like Euclid's division, we can write a is equals to bq plus r, right? So we have to write like this, a is equals to bq plus r. Here a is equals to 225 and b is equals to 135. So 135 2s are, it is 270. So now it is, but it should be less than 225, right? So it is only one time, 135 once. So what would be the remainder? 225 minus 135, it is 90. So remainder is 90. Here remainder is 0. Is it 0? No, it is not equal to 0. So then again we will continue the process with Euclid's division of b and r. Here b is this one and r is 90. So here b, now it will become a and b is 90 here. So 92 is 180. So 180 is greater than 135. So we will go with only ones. 91 are 1. So remainder is what? 135 minus 90, that is 45. So remainder is it 0? No, it is not equal to 0. So again we continue the same process. So remainder gets here, and yeah, again this b will become a in the next step. So b is equals to, so what is here, whatever is r is here, now it will become the b value. So this will become a and this will become b. So 45, how many times I can divide it? 2 times. So 45 2s are 90. So now remainder is what? Remainder is 0. So remainder is 0. Then what is the HCF? So HCF is b. So what is the value of b at this stage? That is 45. Therefore HCF of 135 and 225 is 45. 135 and 225. HCF is equals to 45. So this way we will compute the HCF of any two given numbers. Okay.